Forget frequently asked questions.
Common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs with the Finding Genius Podcast. I have a returning guest, a most welcome guest, Christopher Hendon. He's known as Dr. Coffee. And he does a lot of work in computational chemistry, which we've talked about. But today I want to focus with him solely on coffee because I'm sure most listeners love it. I love it. He loves it. And it's a fun subject to talk about. It's interesting, and it makes everyone want to go drinking coffee. I've noticed when we talk about it. So, Chris, thanks for coming back. How you doing?
I'm good, thanks. Thanks for having me back.
Yeah. Tell me about the world of coffee. How are you marrying that with your chemistry work?
Yeah, so coffee world is it's a pretty vast space in the sense that it's a really complicated supply chain. And when we think about coffee, we think about typically the liquid beverage that we're drinking here in the consuming country. But of course, coffee begins its life as a plant somewhere in the so-called bean belt, equatorial countries that typically are pretty stable in temperature and have mountain. But actually, it's really difficult for me as a scientist to contribute any significant way to any of the work being done from an agricultural perspective. So actually, a lot of my work is done on the consuming side, whether that's thinking about how water chemistry affects the flavor and extractions of coffee, how grinding changes particle size distributions based on tangible parameters like temperature and so forth, or also, more recently, thinking about how we can more efficiently use coffee to get an equally tasty beverage, as determined by your preference, but by using less coffee. So being more efficient. So, in some sense, it's actually much the same as what we do in normal science, right? It's basically a sustainability argument. In this case, we just get to drink the product.
Well, in a typical, where does the waste come from? Does it come from coffee being thrown away that's not being drank and that's no longer fresh because someone makes a whole pot? Or is it that the size or the number of beans it takes to make one cup of coffee is a lot? Yeah.
The largest, from a consuming perspective, I guess we're talking about here, the most wasteful thing you can possibly do is roast coffee and then not use it. So basically it goes stale and we throw it away. Because a lot of energy has gone into getting that coffee to be a single bean that's brown sitting here in a consuming. It's typically not liquid coffee that's the problem, even though liquid coffee is also wasteful because the amount of energy that was used to heat up the water to brew that coffee is, it's a non-zero amount. So certainly from both of those perspectives, there's a tremendous amount of waste. But the waste that I'm actually trying to sort of mitigate, if you like, is if I can brew a cup of coffee, and I'm assuming that the person I'm giving it to is going to drink it all, how could I make that cup of coffee taste equally good by using less coffee beans in the first place? And it's not, that sort of goes in the opposite direction of saying, oh, well, we don't want to throw away coffee beans. So, if there's a finite amount of coffee sitting on your shelf and you can get more cups for the same mass of coffee, then that's a positive. And so I guess the argument at the end of all of this really is can we brew more tasty coffee? That's the goal.
Well, do you know how many beans go into a typical cup of coffee? And when you say reduce it, is 10% a win? Does it need to be 50% to be a win? What numbers are you talking about here?
Yeah. So I don't usually know the number of beans. But I definitely know the mass of coffee. And the reason is, there's certain varieties are really small beans and certain varieties are really big beans. And, obviously a density problem at the but
you don't want to be known as a bean counter either, right?
I don't want to be known as a bean counter.
Go ahead.
So basically, let's say an average cup of coffee contains or was brewed using 20 grams of coffee per cup. Well, if you could reduce the the mass of coffee you use to produce that cup in the first place down to even 18 grams. 2 grams doesn't sound like a lot, but a different way of casting that would be that for every 10 cups, you get a free cup, right? Now, that also doesn't sound like a lot, but in the United States, we drink a lot of coffee. So this is one of these problems. It's a scale issue in the sense that, by reducing the mass of coffee you use by 10%, you're looking at saving, I'm going to try and float a number. I have that number somewhere in my files, but it's going to be on the order of like hundreds of millions of dollars in the U.S.
Well,
yeah.
What could be a big help, and I know this is not that kind of conversation, but Keurig and Nespresso.
Yeah.
If a lot of people go to machines and those companies agree, they find the new brewing method where they can reduce it by 1 gram.
Yeah.
They make their pod a tiny bit smaller. They make their machine a bit more efficient to use less. I mean, that's probably the biggest leverage out there.
Yeah. So actually, I do a fair bit of work with those single serve capsules because you're basically highlighting something that's quite important in the coffee industry, which is those capsules. The expectation of what's going to come out of it, in the flavor, the quality of that coffee is known. It's established, right? It's basically you put the pod in, you get the flavor out. And that's something that's really hard to achieve. So by standardizing that brew method and by making those pods ubiquitous and accessible, there's a real upside to that sort of approach. Now, obviously, you've highlighted the other point, which is, well, what if you could just use a little less coffee to make some, an equally quality product? Well, actually, as it turns out, those devices that produce, either a small beverage like the Nespresso or a larger cup like the Keurig, they actually already have very little coffee in those pods. So in the sense that, like the Nespresso pod can only hold, on around 6 grams of coffee. And the Keurig, I don't know exactly, but I'd estimate in the vicinity of 12 grams of coffee. Previously I was just advocating for 20 grams of coffee per cup, and now we're talking about far less than that. So in some sense, they're already being very efficient from a mass of coffee perspective. But if you were to actually back out the price per gram, those are extremely expensive brew method, in the sense that you're also paying for the container and the benefit of ease of accessibility and so. Okay. So yeah, I mean it's an interesting topic and certainly important because I think Keurig produced something like 20 billion pods last year, or maybe even more. And so if you have something as large produces that, even a 1% difference is a big difference.
Do you know anyone that's gone from field all the way to cup and looked at every step of the coffee process and looked for the inefficiencies and lay that out in a chart?
Yeah, so I mean, I did it recreationally somewhat recently, but it's really difficult to do this because in order to understand where the waste is being generated along the supply chain, you have to include sort of aspects that you're, I guess, maybe not necessarily thinking about. Like, for example, I'll give you a major waste source at the farm side is that we're consuming the seed. We're not consuming the fruit. Okay. So you grow this fruit, you use its seed, and you basically throw away the fruit. So could we use the fruit for something else? Almost certainly, right? You could make biodiesel. You could, maybe turn it into some sort of liquor or something. I don't know what the application is, but there's waste there.
It's cool.
But, and people are thinking about it. I've been reading papers on that topic for about 5 years now. And there's certainly upside because, with making biodiesel, for example, almost always you're taking something that humans would usually eat and instead make fuel from it. Well, in this case, you're not taking something humans eat. You're just going to make fuel from a waste product. So that's actually really positive. But that's really not the major source of, pollution or inefficiency in the supply chain. It's you got to transport the green coffee, which weighs a fair bit. And you got to get it from, let's say, Kenya all the way to New York. And so, it costs a lot to move stuff like that. Those ships they're pretty efficient, but they're probably one of the worst contributors to carbon dioxide emissions in the whole process of the supply chain. And then you also have all the other facets that you consider, like roasting the coffee, which is, of course, a heating process, and you're burning it. So you got to generate, volatiles that go off into the atmosphere. And you see, it's complicated, right?
So are you also saying that a lot of what we're transporting is water in the beans. Like what's the moisture content of a green bean versus a roasted one on average, and how much?
Right.
What's your guess on how much it saves weight wise?
Yeah, so actually it's really well studied. So people care a lot about this because when you're buying the green bean you go over to Ethiopia, you taste the coffee and you've roasted it there in Ethiopia, the water content was like, let's say 12.5 to 13% by mass. But by the time the coffee, gets on the boat and gets all the way to you and so forth, the water content is dropped by like about 1%. And so actually that has significant impact on the quality of the coffee. This is a problem that is related to water activity, was the difference in vapor pressure of water in the atmosphere above the compound that contains water. But people care a lot about that because, water has a really high heat capacity. So when you put in a bean that contains 13% water into a roaster versus one that contains 11, your roast profile is really different, simply just because you have to account for that difference, mass of a material that absorbs a lot of heat. So after you've roasted it, the highest temperature the roaster usually reaches is something like 200 and I need to think about that in Celsius, like 220 degrees Celsius. So you're well above the boiling temperature of water. So basically at the end of a roast, there's very little water left. I'd say less than 1%.
Huh, really?
Yeah,
Wow.
yeah. That's actually why coffee, if you leave coffee in a humid, they say keep it in a cool, dry place. Well, the dry is really important because it wants to absorb water from its surroundings because it's so anhydrous.
So if my cell phone falls in the toilet, I get put in a bunch of roasted coffee. That might dry it out like rice.
Oh, yeah, I'll tell you what, roasted coffee, rice, they both do a pretty good job of it, yeah.
So, there's a lot of factors. I can see what you're saying. I guess you could ship the green coffee under, in a nitrogen blanket, if you could do that in a container, maybe, under colder conditions, ways to prevent moisture from leaking out, but not let it go moldy. And they're storing it. There's tons of factors the whole way.
Yeah, that's right. Well, yeah, so some people put it on an airplane, right? But that's really inefficient because airplanes are really good at making. So for an industry that cares a lot, at least on face value, cares a lot about sustainability and so forth, these are the sorts of things that you should think about in the coffee industry because they're people really care about this stuff, and it's also so widely consumed that you can really make a difference by being sort of have a clear mind about what matters to you from.
Well, where do you feel like you have the most control and ability to put your knowledge to work? Is it the brewing process?
Yeah, sure. Yeah, so I got into coffee by looking at how water chemistry and dissolved minerals in water augmented the flavor of coffee. And this is something it's a very complicated topic in the sense that basically every coffee has different flavors contained within the bean, and you're using the water to access them. So you can't just say here's one water that works for all coffees, because indeed maybe there are several waters that could make the coffee taste good. And also good is a moving target because even you and I may disagree on what we enjoy. So we got into this water chemistry problem thinking about, okay, well, at least we can scientifically describe what the minerals would do to the extraction and the perceived flavor. And so we got a handle on that, and it can be summarized very simply in that bicarbonate, which is just basically baking soda, solvated in water, can turn on or off acids depending on its concentration. And so coffee is an acidic beverage, and so if you have high levels of bicarbonate, then you won't taste the acids, and typically we don't enjoy those. But then on the other hand, you have the metals that are solvated, like calcium, magnesium, and those we tend to think of as flavor extractors. They help extract certain flavor profiles from. This is particularly. Go ahead.
In general, we'll continue with this in just a second, but people like to have hacks. I do too. Are there any quick rules of thumb you could give before we continue for people to change the taste of their coffee?
Oh yeah. So you can get creative and actually mix. You can mix your own minerals into water, but that's a real pain in the neck. So honestly, what you probably want to do is you can just go buy Dasani, which is really soft water, low in mineral composition. And then you can buy yourself Evian, which is really hard water, high in mineral composition. And basically, Evian has so much bicarbonate in the water that it turns off all the acid in coffee. And if you brew, if you put your Evian in your kettle and then heat it up and brew your coffee, you will taste coffee that tastes truly dreadful. I don't think anyone enjoys it. And if you brew it with the soft water, you'll also taste coffee that is really not that enjoyable because it's going to be far too acidic. Because you don't have any of that bicarbonate in the first place. And so really, honestly, there's some sort of delicate balance in the middle. And we don't have a single recommendation for the best water. But I guess what we want to show, and that hack, if you like, of taking the two different waters, is just to simply demonstrate the power of water to you as a consumer. And then once you understand that, then you may begin to understand why, you go to your local cafe, you buy the beans, you love them there, you take them home, it tastes like garbage. And you're like, oh, are they selling me different quality beans? Am I not as good as them? What is it? Well, I guarantee you with almost certainty that it's actually just differences in water chemistry.
Yeah, it's weird. I've never thought about the water part of it. I've just thought about the beans and the brewing process. Yeah.
Right. Yeah, the water, the water is so important that it can take a coffee, which is like, I have this one notable memory where we brewed this Ethiopian coffee is fantastic. When I brew it with water low in bicarbonate, you tasted like black tea and sort of like ripe red fruits, like things like cherries, black currants, that sort of thing, and red currants and stuff. And it was really amazing. And then we brewed it with hard water. We brewed it with Evian, and it takes all of those acids that you think of as fruits and wonderful flavors, and basically turn them all into tasting like they're conjugate bases. And conjugate bases to humans taste really bad, chalky. And this particular coffee tasted like fish. So it went from being something that, was really an enjoyable experience to going to something I really, really wish I hadn't done. But that made me really think about this. It's like, what if I gave that coffee as a gift? For example, if I gave it to you and I have no idea what you're going to brew it with, and I say, this is great, you're going to love it. And you go home and you brew it and it tastes like fish. Are you going to think, wow, this guy really knows nothing about coffee, So that's one of the problems.
You're also talking about just drinking it black is my guess. But I'm thinking like I should use really soft water so I get everything out of the coffee I want. And then to counteract the acidity, I always put cream in it.
Sure.
If I do that and a little sugar, maybe I'll get the most delicious, like full flavored expression of the bean I could possibly get. Like, what do you think?
That's right.
That?
I mean, you basically arrived at the sort of the simplest conclusion that's also a good conclusion. And I've been saying that to people for a while, but not in previously we were saying use harder water, but special type of hard water that doesn't have bicarbonate in it. So you get all the flavors out, but you don't buffer away the acid. But now I realize, how difficult that is to achieve. It's just easier to use soft water and, change your brew method a bit,
So again, just to repeat, so soft water will have very few minerals dissolved in it. Like what are the predominant minerals that are dissolved in water that we drink?
Yeah.
And if it's soft, what's missing?
Yeah. So basically water typically, unless you're catching rainwater, water, moves across land. And so as it's moving across land, it's picking up minerals from the ground. And so if it goes across, certain rocks, it'll dissolve some calcium, some magnesium, some carbonate, which turns into bicarbonate. If you're near salt water, then you're going to have a little bit of sodium and chloride in the water as well. And those are basically it. That's, you get a little potassium sometimes, but basically water is just made up of calcium, magnesium, bicarbonate, chloride, and sodium, really. And so hard water then is sort of delineated from soft water by the concentration of specifically calcium and bicarbonate. And the reason people care about that is that if you heat that up, it can form limescale, that white material in your kettle. And so, from a perspective of plumbing, you don't want to have limescale depositing in your pipes. So, basically, that's why people care about it. But
have you tried doing an extreme? Like, have you used distilled water to brew coffee? And what if you went to a semiconductor plant and used like ultra pure water?
Yeah, sure. We do it all the time, actually. Yeah. So that doesn't, contrary to what people believe about drinking that being bad for you and stuff. I mean, it's just water at the end. But because it doesn't have any minerals in it, what you end up with is you have a very acidic cup of coffee, if not sour. And this of course depends on roast, because the darker you roast, the less acid you have. But basically, yeah, if you use deionized or millieq water or something from your local semiconductor industry, if I went up the street to Intel and used some of their water, basically you'd get a really acidic cup of coffee. Now, whether that was enjoyable to you or not is a different problem, but it certainly sort of goes to the extreme and says, like, hey, look, no minerals at all means that all the flavors in that cup can be tasted, for better or worse.
So if people can't really change their water, or they don't even have a consciousness of it, then they think, okay, it's the bean, it's the grinding, it's all these other parts of it.
Mm-hmm.
So I guess someone has to ask themselves, like, okay, if I drink coffee black, I have one set of issues. If I put milk and sugar and all that, then, I don't have those issues. I have maybe other ones. I can mask the coffee, or maybe brew it in a way where more flavor comes out. I can tolerate more sourness. So,
yeah. So you're basically highlighting the point is that the industry can get as complicated as you'd like. You can start to think about, well, you're talking about, basically what I've been mentioning the whole time is a black coffee argument. And most people in America don't just drink black coffee. They add, cream or milk or sugar or something, and of course those are valid brew methods and valid ways to drink your coffee. It just makes it more difficult for me as a scientist to make statements about the chemistry, because your milk is equally complicated. It had, various different cows, a different fat content, and all this other stuff. So, it makes it more difficult. It's not me being a snob. It's just trying to simplify the scientific process.
Well, what can you do? I guess at home, the first thing to recognize is, do you drink black coffee, or do you put milk and sugar in it?
Right.
And if you do, so what would be, just to restate, what would be your recommendation? If I drink black coffee, what should I do to make sure I have really good coffee? And if I drink, if I put milk and sugar in it, then, what do I do instead?
Yeah. So if you drink black coffee, and you're already happy with your coffee that you're drinking, then I'm not really going to give you a recommendation as to how to improve it. But we can give you a recommendation of what to try to have the experience that, that I'm talking about. Like, for example, maybe you don't like acidic coffee, but you're interested now in trying acidic coffee because you don't think the coffee you enjoy is acidic, right? So if you want to try acidic coffee, just go buy yourself some soft water and do exactly the same thing you normally do, but use that soft water to brew your coffee. If it tastes the same as what you normally do, there's a good chance you were already using soft water. Some places like where I am in Eugene, the water's soft coming out of the tap. Makes pretty acidic coffee, tastes pretty good. Don't have to work too hard. But that's the water chemistry is one thing you could focus on, but you could also then focus on the various different coffees. Coffees from Ethiopia, Kenya, Rwanda, Burundi, East Africa have very different flavor profiles to those coming from Brazil, Sumatra, Hawaii, Vietnam. And you may have your favorite, whether it's, a washed Colombian coffee from the Huila region that tastes like chocolate and green apples or whatever. And I might also like that coffee, but my favorite would be an East African coffee. Then, that's sort of the elegance of this, is that we get to have that communication. The one point I'm trying to overcome here is that if I tell you that I love this green apple flavor in this Ethiopian coffee, and you love that dark chocolate and Brazil nut flavor coming from your Sumatra, and we switch coffees, and now you don't taste what I said and I don't taste what you said, then we've got a problem. And so that, I'd much rather have the experience you intended me to have.
So when you try coffee, if you're going to try it first, you don't know if you like it, is the best way to do it is to brew it with real soft water, tolerate the acidity, but make sure it has the flavor profile you want. And then you could dial that back by changing the water.
Yeah, well, that's certainly what some people do. That's a lot of work for your average consumer. You know what you can really do, actually, is you can contact the roaster. So, every coffee has been roasted by a company. You can send the roaster an email and say, hey, what water chemistry do you use to quality control? Because, the roaster has to brew their coffee to make sure it tastes good. So you can ask them what water chemistry they're using, and then you can say, do you have any recommended bottles of water that you'd like us to try your coffee with, and then see what the roaster says.
What about now the brewing method? Percolator versus, and I was thinking too, when you talk about water chemistry, let's just jump for a second to shots. How does the water, they're using literally steam to
to pour through the grinds in a shot, or is it water, or is it just high pressure water? And how does chemistry affect it then?
Yeah. So the brew method does make a big difference. So I actually haven't brewed myself with a percolator, the old school one that sort of cycles the water through the bed. But I've tried basically every other method. The brew method does matter, but you can break the brew methods down into roughly two categories. One where either the coffee's in contact with all of the water the whole time. So an example would be an AeroPress or a French press. And then the other type would be where the water is flowing through the coffee. And that would be an example of like a pour over or a Mr. Coffee, a drip coffee or an espresso. Now, obviously, espresso seems really different to a filter coffee in the sense that you're using high pressure hot water, whereas in a filter coffee, you just boiled the kettle and are pouring on it. But really, the water is flowing through the bed versus being, submerged. You have all the coffee submerged in all of the water. The difference in flavor profiles between those is pretty significant, and the difference in chemistry is also significant. In part because if you just compare whether it's full contact or flowing through, from a chemistry perspective, the full contact one you have a lot more water that doesn't have a lot of coffee stuff dissolved in it, versus the local gradient of concentration as you flow water over coffee is relatively high in the flow through method. So let me restate that a different way. Basically, in one brew method where all the coffee touches all of the water, you have a constant excess of water. And on the other side, you're constantly bringing new water in contact with coffee, but you're not sort of progressively diluting your cup. And so as a result, that's you get really different flavors. But espresso then is really different again, because the addition of pressure means that you can actually condense things like carbon dioxide and other stuff into the water. So you get, a different flavor profile once again. And so that's why there's so many brew methods, is because each one does do something ever so slightly different, but it is different.
Do you ever wonder how anyone could have a good cup of coffee then?
I wonder about that every day. It's actually somewhat of a miracle that whatever we've managed to do, and I have my own ritual in the morning, and I'm sure that you have your own one. It's remarkable that we achieve some sort of flavor profile that we seem to like consistently day in and out. But
maybe people aren't coffee snobs. Maybe because the taste is so different that's why they love to customize it, because they need to in order to really get it the way they want it.
Yeah, well, I honestly actually think that's right. I think they're in part people who think that they are coffee snobs really just they just enjoy the process, the romance of brewing coffee and the flavor differences that one can achieve from looking at things like origin and brew method and stuff. But at the end of the day, my dad at home brews excellent coffee, and he does it in the most simple way. He takes a couple scoops of coffee and pours some water on it. It tastes great. And he's not a snob. He just brews coffee like a normal person. That maybe that also points to something more fundamental. Like maybe brewing coffee is really not all that difficult, and maybe we just want to make it more complicated because it's fun.
Well, it's just interesting to see the different, methods and everything. I mean, from what I've heard too, there's the, once the beans are roasted, it seems like a lot of people say let them rest, for a few days to a week. Otherwise, you don't let the trapped gases escape, etc. Then there's a whole roasting process. Do you use a a temperature ramp that's fast? Do you use post temperature? I mean, what do you roast the coffee with? I mean, there's tons and tons and tons of variables. Are there a lot of people studying all of these variables, or is it too massive? Or like, what do you see the industry does to, like, where's the industry headed? What are they looking at? What are they trying to figure out?
So the coffee industry is pretty interesting, because basically what they're trying to do is, if you ask most specialty coffee roasters, their goal is to make the coffee brewing process as simple as possible. So they're trying to roast coffee so that no matter what you did at home, you're still going to get something tasty. So on one hand, people do care a lot about all these different variables, but on the other hand, companies are trying to make sure that the variables are not overwhelming and distracting you from the quality of their product in the first place. And you see this with the emergence of more convenient brew methods like the ones we talked about earlier, but also coffees that have flavor profiles that aren't affected that strongly by water chemistry. For example, coffees that don't have high perceived acidity, like the Brazilian, Sumatran, etc. coffees. And you also see the increasing prevalence of more simple brew methods, like I can go to the supermarket now and I can find filter papers for a pour over coffee. And, that's basically it. That's what people are drinking a lot of is, you start out in the morning, you grind your beans, or maybe you've got them pre-ground and you go for it. There's value in that.
Gotcha. What kind of personal experimentation are you doing then? Where is your focus, on the water chemistry side, or what are you working on?
Yeah, I did the water chemistry in 2014, 15, 16, sort of. I'm not saying it's solved. Okay, that's not a solved problem, but I can tell you that the chemistry that underpins how acids and flavors are communicated through that water, that's understood, right? I can talk to somebody I've never met, and if they give me their coffee and their water, I'll be able to sort of somewhat predict the flavor that I could expect from that. Now that doesn't tell you whether you like it, but at least we've got an understanding of why. And so actually from the coffee industry perspective, that's a tremendous success because it's one of these rare opportunities where the whole industry can embrace the fact that actually every cafe is different. Even if they're competing in the same space, they can't have the same product because their water will be different. And even two cafes next door to each other can have different water. So it really
I found that this is one coffee place I was going to for a long time. Literally, the barista made it different.
Oh yeah, there's that.
I swear to God, this one guy I would get like an ice drink. So some people he always made it great, and I was like, "What are you doing to make this so good?" So he would put it was like a latte or something. So he would put the milk in, and then he put the shots on top of it. And then he would put the ice on last. He'd pack it on like a snow cone. And I said, why do you do that? He goes, because if I put the ice in at any point before, it's, the espresso shots are going to melt it. So you get a lot more water in your drink. This way you get the least amount of water. And he was right. It was like awesome, and also when he put the shot in, he would tamp it down, but he had this thing that just, you went over the surface of the shot and it just made it all even. It was like, those Japanese rock gardens, you rake the rocks. And he said supposedly that makes it a little more even when it goes through the the head of coffee.
Yeah,
but he made it great, and same coffee, same everything, and someone else would make it. It was like, blah,
Yeah, there is always that human variable at the last step. I guess that's kind of why a cafe or a coffee shop is not exactly how do I want to phrase that? It's basically you're going there and paying for a drink, but actually the drink is somewhat more of an experience. It's not really, you're buying the whole thing. You're buying the ambiance of the space. You're paying the barista for their skills and their services, and you're also embracing the fact that maybe there is a human component here that that actually makes this industry kind of variable and fun. That's actually kind of highlighted what one of my active areas of research is that I'm not trying, when I talk about sustainability and reproducibility and these sorts of stuff, I'm not trying to homogenize barista A that makes a tasty one for you and barista B that made a less tasty one. I don't want them to make the same cup, right? I just want barista A to be able to make the same flavor profile that they intended every time, and barista B to make the same flavor profile they intended. Now, whether they're different or not, that's part of the fun. Because that means that I can then go to a new cafe, and if they're, at least I know with confidence that the product they gave me is what they meant, they intended it. Then I can have a preference as to whether I like that cafe more or less than another cafe.
Yeah, I've noticed if a barista is in a bad mood, the coffee's not as good.
well, there's
Especially if the barista is my wife, sometimes. So
there's always the intangibles, the hard stuff to control.
Well, how about the brewing method? Any insights there? Like you said, you've seen it done all kinds of ways. Just in your personal experimentation, again, any tips what to do and what not to do to make the coffee more like you want?
Right. So I can't tell you what the best brew method is, but I can tell you that there are a lot of brew methods that have inherent variability. Like, for example, a hand pour over. You can pour that water 100 different ways. You could pour all of the water in that cone, or you could pour just a little bit slowly. They're going to have different flavor profiles because, on one hand, you have a lot of water contacting not a lot of coffee. On the other hand, you have a lot of coffee contacting not a lot of water. You get the idea. So I don't really like those methods when I'm trying to communicate ways to brew consistent coffee, even though that's the method I use at home. But actually, the method I think is probably the most useful in terms of communicating consistent flavor is something where all of the water touches all of the coffee the whole time. So, for example, there's a benefit from a French press as well, that you can grind your coffee coarser. And that's good because most of the grinders that we have at home are not really that good at making uniform small particles, but it's quite easy to make relatively large pieces. And so something like a French press or an AeroPress where you add a known amount of coffee, so you weigh the mass of coffee you're going to use, you add a known amount of water, either volumetrically or gravimetrically, and then you brew it for exactly a known amount of time. Those are the three variables there, right? So with that, you can then start to isolate whether it was your brew time, your mass of coffee, or your mass of water, or didn't like.
What about a temperature of the water? Is there a range where it's too hot or?
Yeah, so people often describe, boiling water as burning the coffee. You probably heard that before. Obviously the coffee was roasted like 220 degrees Celsius, and water can only get to obviously 100 degrees Celsius at boiling. So you're not going to be re-roasting the coffee to generate more burned. But at higher temperatures, you are able to extract more of the burned flavors from the coffee, at least quickly. And so typically people don't like using super, super, super hot water unless they're using a coffee that has been roasted so that it doesn't have a lot of those burned flavors in the first place. So like a lighter roast, if you like. And then in that case, you probably want that hot water because you want to get all the stuff out of the coffee that tastes good to you. So temperature obviously plays a major role. I've given actually numerous talks on this. It's a kinetics problem. So I encourage you, if you're interested in that, you can check out the American Chemical Society talk that I gave on the topic. But basically, the sort of executive summary of that is that water temperature does change not only the amount of coffee you extract, but also the composition, like the cross section of flavors you extract. And I typically, because I think it's easy to then just boil your water and then use it from boiling, because at least it's a reference. So I typically boil my water and I brew coffee that way. But certainly I know a lot of people in the industry prefer something closer to 92 to 95 degrees.
Oh, that pulls out a lot less of maybe if the coffee's burned, a lot less of the burned components are.
Right. Yeah, it's worth pointing out that when I say burned, I don't necessarily mean that in a negative way. There's benefits from roasting coffee dark. You get to develop some of the caramelized flavors. You think of coffees tasting a bit like graham crackers, toasted marshmallows, that sort of stuff. I like that, right? So, it's nothing negative there. It's just that in order to develop flavors like that, you have to roast the coffee darker. And dark coffee also makes flavors we don't like. So it's a balancing act.
What about cold brew? What's happening when you're brewing the coffee and then you let it sit there for let's say 48 hours? What's going on then?
Yeah, so a lot of these chemical processes are kinetically limited, meaning that in principle you could extract the stuff, the coffee material at high temperatures, but in practice it just simply takes time to get those things to move into the liquid. So at cold brew, while you don't have the temperature, so you're not going to get certain compounds being extracted into the cup, you do have time on your side. So you can get higher proportions and higher concentrations of things that were limited by the rate in which they would move from solid into liquid. That makes it really difficult to predict the flavors because the coffee roaster almost always did not roast their coffee intending for you to brew it cold. So in some sense, it's the Wild West. You're going into the dark there because you just don't know. You don't really know what you're going to get out of that coffee if you were to let it sit in water for 48 hours. But that doesn't mean it's not good. In fact, there's a lot of really good cold brew.
Yeah, I've had it. It's delicious.
Yeah, it's just a good example. I mean, I guess maybe you and I probably have had a similar experience with this, but cold brew often features sort of, in a positive way, more like woody, chocolatey, spicy sort of notes. It reminds me of like fancy chocolate compared to
that's what I like. Yeah. They have a lot of these like fruit coffees, which I hate. I know a lot of people like them, but I'm like, blah.
Yeah. So exactly. So compared to those like hot coffee extractions that taste really acidic and like pineapple and blueberries and stuff.
Yeah, exactly. Interesting. I had one time at like the Starbucks Reserve in New York City. they have this siphon coffee, which is really good. But they also use, I guess, probably their best roasts that are out there. But for some reason, maybe the siphon process, it was really complicated and crazy, but it was delicious. Coffee.
Yeah. Yeah. So,
I don't know if you've ever done that.
Yeah. So the siphon coffee is interesting because actually that's a brew method that uses basically boiling water the whole time. So you've had the experience then where you can use really hot water, but you don't get those crazy burn flavors. You get this beautiful cup of coffee, right? And in part that's because also, Starbucks Reserve is buying high quality coffees. They're buying the same coffees, more or less the same coffees as, the specialty coffee shop down the street, But yeah, that siphon brew method is a good one. It's a really consistent brew method. So, consistency is king in science. So that's a good thing. And, I wish do you remember the coffee you had?
No, I have no clue, but I just remember it was just delicious. It was really, really good.
Yeah. Yeah. Well, so the good news about that is that, you think it's the brew method that did that for you, but honestly, it wasn't. The brew method is just really not as important as people think. It really was that you probably had a well-roasted coffee.
Yeah. What makes a high quality coffee versus crap coffee?
Yeah. So you can look this up. There's a score sheet that the coffee buyers use called it's the Specialty Coffee Association cupping form. And basically what it is a series of metrics that you use to grade coffees out of 100. These things included on this score sheet are aroma, aftertaste, acidity, that sort of stuff. And you're scoring it between 6 and 10. So any coffee that scores above an 80 is called a specialty coffee. Now it doesn't mean it's arbitrary, right? It's just a number, but it just means that it fetches a different price point. And anything below is commodity. So basically what we're getting at here is that, okay, certain coffees score high on the score sheet, certain coffees score much lower. If you happen to be a person that likes a lower scoring coffee, that doesn't mean you're a Philistine, right? It just means that you don't necessarily value acidity in the coffee. Maybe it scores poor in acidity, it scores poor as a coffee, but that doesn't mean anything. So the particular coffee that you had in that experience with your siphon, they could have very well bought an 85-point coffee. And, comparing that to what you may find in your average supermarket brand coffee is going to be day and night different. Supermarket brand may be a 68-point coffee. And the difference between 68 and 80 is huge.
Huh, interesting. What about, just jumping to another subject, has anyone or you looked at the fermentation of coffee, the drying of it? Has anyone looked at the coffee microbiome? I've heard that coffee ferments a bit.
Oh, yeah.
Anyone studying that part of it?
Oh yeah. That's big business. So there's private laboratories that are developed around understanding that process. Just for the average listener here, basically a coffee, you pick it, you remove the fruit, you end up with the seed. The seed gets fermented for, let's call it 24 hours. And then that seed is then what dries out a little bit. And then that's what we roast. So that fermentation process is much the same as chocolate, and really people are really exploring that a lot, because it turns out that in that 24 hours, you can control a lot of the flavors that you can generate way down the chain at the roasting stage in that 24-hour time period. So if you could tell a farmer that was struggling to get their coffee to score 80 points, let's say they were consistently a 78, then all of a sudden you say, hey, all you need to do is add carbonic acid to that fermentation tank and you're going to score 85. That's a big deal. That's a price point difference for the coffee farmer is huge.
So does anyone try to leave the cherry on the coffee and let it sit for 24 hours and then take it off?
Yeah, so that's called the natural process, actually. So if you leave the cherry on and let it dry out in the sun, actually takes a while to dry out. Turns into a bit like a raisin. You then remove the raisin and you get the beans out. That process imparts like weird fermented fruity flavors. Probably not to your taste, given you like the chocolate stuff.
Yep.
Yeah, but the natural process makes sort of like these kind of winey, boozy, fruity things. And I love that, but not every day. It's interesting. The other alternative is to wash all the fruit off and then do the fermentation, with the washed bean, and that indeed gets the title washed coffee. Washed coffees typically don't have any of those boozy, crazy notes. And my favorite coffees are washed Ethiopian coffees. They're fabulous. They taste, like tea almost.
Have you ever had, I heard there's a coffee that, I don't know, a civet eats, poops out, and then then it's a very expensive one. Have you ever tried that?
Oh, yeah, sure. The reason that works is because the civet uses the fruit for energy, and then it uses its intestines for the fermentation process. So, it's much the same as what we're doing. It's just, done inside an animal. The problem is that I'm not aware of a single coffee that the civet has processed that scores higher than an 80 point, right? So on the specialty coffee tasting chart, I'm not aware of one that actually has the flavor profiles that I'm looking for in these high-end coffee. And that's just that, maybe that's a processing method. Maybe it's the civet chooses to eat inferior fruit, although I doubt that. I don't really know why that is, but basically, yeah, I've tried it and it really doesn't taste good.
Okay.
Yeah.
Well, what is your favorite coffee experience ever? Do you have one? Like, what was the most delicious coffee you've ever had, and do you know why?
Yeah, sure. So I get a lot of friends who, work in the coffee industry, and they send me their beans, and I go to these meetings, these conferences, and by the way, if you're a scientist and you're interested in coffee, it's a real party there. It's fun. So you go there and you get to try all these interesting coffees and stuff, and often go home with a lot of these coffees. And my favorite, I don't have a single experience that I love the most. But I'll tell you that anytime someone gives me coffee that they are really excited for me to try, and I get home, I'm equally excited to try it. And so, about 80% of the time, the coffee is pretty good. 10% of the time it's outstanding, and 10% of the time it's not all that good. And I wonder, actually the really exciting times for me, the really memorable ones, are either when it's either of the 10%. When something really went wrong. That's really interesting, and that's really fun for all of us, because then we can learn something. And if something went really right, then I can also learn something. Like, how the heck did they do that? That was amazing. So, I have that experience probably twice or three times a year.
Good. Well, very good. Well, Chris, we're out of time. What's the best way for people to learn more about the coffee side of your life and the works that you put out and the research you're doing?
So I actually I curate a coffee library for the peer-reviewed articles I found on coffee that I think are interesting. They can go to the website, my website, and you'll find the links at the bottom there for that. You can also always email me, but then I would strongly encourage you to check out probably the American Chemical Society talk. That has a lot of good content in there and some good references. It's a little more scientific, right? It's got a little bit more chemistry, but I'd encourage you to stick with it, because it really is worthwhile. It's a fun topic.
Well, very good, Chris. I hope that people get some good tips on how to modulate their experience and improve it. And thanks for coming back. I appreciate it.
Yeah, thanks, Richard. I really appreciate it, man.
If you like this podcast, please click the link in the description to subscribe and review us on iTunes.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.